Welcome back to the Before AGI podcast, everyone. We're going deep today, diving into a topic that I think is fascinating and really important for understanding where AI is headed.
Oh, yeah, definitely. This is one of those things that people don't always talk about, but it's actually super relevant to, everybody.
Exactly. Today we're talking about, well, you could call it the money side of AI, the economics of artificial intelligence.
Right, because we hear about all these incredible things AI can do, but how much does it actually cost to create these systems, to put them to work?
And that's what we're here to unravel before a whole stack of reports, data, all sorts of stuff about the financial side of AI, from the crazy investments needed to train those cutting-edge AI models.
To the actually surprising trends in how much it costs to actually use them once they're trained.
So our goal, as always, is to break this all down for you, give you, the listener, the insights you need to understand this whole world of AI economics, and we'll try to keep it engaging.
Yeah, definitely. Cut through the jargon, make it clear what these financial forces mean for the future of AI, where it's going, how it's being used, all that.
Perfect. So let's dive right in. And I think the best place to start is with the big ticket item, the area where the biggest investments in AI are happening right now.
You mean the training of those huge AI models?
Exactly. These advanced AI models, the ones that are making headlines, they don't come cheap.
Nope, not at all. In fact, training costs have, they've exploded in recent years. There's this report from altindex.com, and it says that since 2020, training costs have surged to get this by 4,300%.
4,300%. That's almost hard to even imagine. Can you give us some concrete examples? Like, how have costs actually changed over time?
Oh, for sure. Let's take a little walk down memory lane. Back to 2017, remember Transformer? Kind of a big deal in AI. Well, back then, training that architecture cost about, roughly $930.
Okay, so back then, not too bad.
Not at all. But things started to ramp up. Just a year later, in 2018, you had Google's BERT large model. The training cost for that was estimated at around $3,288. Still relatively manageable.
Yeah, I mean, compared to what we're about to talk about.
Exactly. It's like a drop in the bucket. But by 2019, things were already getting serious. Meta's RoBERTa large model, the estimated training cost $160,000.
Whoa. Okay, so we're seeing a pretty steep climb already.
And the climb just keeps getting steeper. In 2020, OpenAI's GPT-3, the one that everyone was talking about, reached a whopping $4.3 million for training.
Millions, plural now.
Right. And this is where it gets really interesting because the trend just accelerates. In 2021, the Megatron-Turing NLG 530B, that was a collab between NVIDIA and Microsoft, that one's estimated to have cost $6.4 million to train.
It seems like every year the cost jumps significantly.
It does. And in 2022, you had Google's LaMDA coming in at $1.3 million, but then their PLM model with a massive 540 billion parameters.
Parameters, for our listeners who might not be familiar.
Oh, good point. Think of parameters as like the adjustable knobs within the AI. The more you have, the more the AI can learn and adapt. Anyway, PLM's training cost was estimated to be a massive $12.4 million.
And that brings us to 2023, where the numbers get, well, let's just say mind-blowing.
Exactly. OpenAI's GPT-4 estimates for the core technical expenses are somewhere between $41 million and $78 million. But when you factor in all the personnel costs, it's likely well over $100 million.
That's just for one AI model.
Yeah. Then there's Meta's LLaMA 270B, another significant investment at an estimated $3.9 million. But the one that takes the cake, at least for now, is Google's Gemini Ultra. Estimates for this one, and this is excluding staff salaries, range from $30 million all the way up to a staggering $191 million.
Wow, those figures are really hard to wrap your head around. And it's not just the numbers themselves, it's the fact that we're talking about some of the biggest names in tech here. OpenAI, Google, Meta, NVIDIA, Microsoft. These are not small startups.
Definitely not. This is a high-stakes game. These companies are pouring massive resources into AI, and it raises a lot of interesting questions, like what advantages does this kind of concentrated investment create? And what challenges does it present for smaller players who are trying to get into the AI game?
Yeah, definitely something to think about. So let's talk about what's actually driving these massive costs. It can't be just one thing, right?
No, it's a whole bunch of factors coming together. And one of the biggest is hardware. Those powerful processors that AI needs, those GPUs and TPUs we talked about, they're not cheap.
GPUs and TPUs. Can you remind us what those are again?
Oh, right. GPUs are graphics processing units. They were originally designed for, graphics, gaming, that sort of thing, but they turned out to be really good for the kind of calculations that AI needs. NVIDIA is the big name in GPUs, and their high-end A100, just one of those, can cost you between $10,000 and $15,000.
That's just for one.
Yep. And then you have the newer NVIDIA H100s. Those can cost over $4 an hour just to rent. Then there are TPUs, tensor processing units. Those are Google's specialty. They're specifically built for AI workloads. And their V4 pod, that's a monster with over 4,000 TPU chips. That thing costs $32,200 per hour to rent on demand.
Okay, I'm starting to see where some of these training costs come from.
Right. And just to add to that, for Gemini, hardware alone accounted for a massive 47% to 67% of the total cost.
So it's a major chunk of the budget. And speaking of budget, all that high-powered hardware, that's got to take a lot of energy to run.
Oh, absolutely. Energy consumption is another huge factor. I mean, think about it. These AI models are essentially crunching numbers nonstop. For Gemini, energy costs were estimated at about 2 to 6% of the total.
2 to 6%. That might not sound like much.
It's not in relative terms, but when you're talking about these massive training clusters running 247, those monthly electricity bills can easily hit $50,000 to $150,000.
Whoa. Okay, so the lights are definitely staying on.
They're better. And then there's the cooling. All that computing generates a ton of heat. To keep everything running smoothly, you need industrial-grade cooling systems. That can add another 20 to 40% to your energy bill.
So we're basically talking about running a small, superpowered data center just to train one of these AI models.
Yeah, pretty much. But it's not just the hardware and the energy. There's another huge cost factor, and that's the people.
The human side of things.
Yeah, exactly. The brains behind the operation, those data scientists, the AI engineers, the researchers. You need top talent to build and train these models, and that talent is in high demand. For Gemini, staff salaries and expertise were a whopping 29% to 49% of the total cost.
So the human element is almost as expensive as the hardware itself.
In some cases, even more so. And then you have the models themselves, larger models with billions or even trillions of those adjustable knobs, those parameters we talked about. Those require more computational power and therefore more time and money to train.
It's like the more complex the model, the more it costs to teach it.
Exactly. And speaking of teaching, let's not forget about the data.
The data, you mean the information that the models learned from?
Right. These models need tons of data to learn effectively. And not just any data, it needs to be high quality, relevant to the task you're trying to teach the AI. Acquiring, processing, and storing all that data, that's another huge expense.
So it's not just about the raw computing power, it's about the whole ecosystem around it.
It's everything. The complexity of the tasks you're teaching the AI, the sophistication of the training methods. Then you have the infrastructure, the servers, the networking, the maintenance. All of that adds to the cost.
It's like a perfect storm of expensive necessities.
It really is. And it's not just anecdotal. There's research to back all of this up. Organizations like Epoch AI, they track trends in AI computing. They found that training costs have been growing at a rate of 2.4 times every year since 2016.
Wow, so it's not slowing down.
Not at all. They even predict that by 2027, those big training lawns could cost over $1 billion. The Stanford AI Index report also highlighted how crazy compute costs were in 2023.
Okay, I think we're starting to get a picture of just how massive these investments are. But I do remember reading something about DeepSeek V3. And it seems like their training costs were surprisingly low.
Yeah, that's a really interesting case. DeepSeek V3 reported a training cost of around $5.6 million, which seems way lower compared to the tens or even hundreds of millions we've been discussing. But there's a catch.
Oh.
Yeah, that reported number, it likely only represents a small part of the total investment. They probably didn't include a lot of the initial research and development costs, the money they spent gathering and cleaning the data, and all the salaries of the people involved.
So the reported cost might be misleading.
Exactly. Some experts estimate that the true R&D budget for DeepSeek V3 could be closer to $100 million.
Okay, so the public numbers don't always tell the whole story.
Nope. It's important to remember that training costs are just one piece of the puzzle.
Right. And speaking of other pieces, let's shift gears a bit. We've talked a lot about the skyrocketing costs of training AI. But I understand that when it comes to actually using these trained models, what's known as inference, the trend is surprisingly different.
Yeah, that's where things get really interesting. While training costs have been going through the roof, the cost of inference, of actually putting those trained models to work, has been going down. And not just going down a little, it's plummeting.
So wait, it's becoming much cheaper to actually use the AI.
That's the amazing thing, and this has huge implications for making AI more accessible and useful in the real world.
Okay, so how much cheaper are we talking about?
The data here is pretty incredible. In just 18 months, the cost of achieving intelligence comparable to GPT-4 has dropped by a factor of 240.
240 times cheaper.
Exactly. That means it went from costing about $180 per million tokens. Tokens are basically the building blocks of text that these models process, to less than $1.
So what's driving this dramatic decrease in inference costs?
Well, there are a few things happening. First of all, there's a lot more competition in the AI space now. There are more companies offering AI models and services, and that competition is driving prices down.
So it's like any other market. More competition means lower prices for consumers.
Exactly. We're also seeing the rise of really powerful open source models, like those from Meta. These are freely available models that anyone can use, and they're putting pressure on the companies that are trying to sell their proprietary models.
Makes sense. So competition is a big factor. What else is contributing to this downward trend?
Well, there's been a lot of innovation in hardware. We're seeing specialized chips being developed that are specifically designed for AI inference.
Oh, like those TPUs we were talking about earlier.
Those are great for training, but for inference, there are other chips, like Amazon's Inference chips. And companies like Grok are coming up with innovative designs, too. These specialized chips are much more efficient at running trained AI models than traditional processors.
So better tools for the job, leading to greater efficiency and lower costs. Makes sense. What about the fact that more and more people and businesses are using AI now? I imagine that plays a role too.
Oh, absolutely. It's all about economies of scale. As AI adoption grows, the companies providing these inference services can spread their fixed costs over a much larger user base, so the cost per user goes down.
So as AI becomes more widespread, it actually becomes more affordable to use. That's a pretty positive feedback loop.
It is, but we need to remember that there are different ways to actually use these AI models. You can use cloud-based services, or you can run them locally on your own devices.
That's right, there's the cloud versus the edge. Can you explain the cost differences between those approaches?
Sure. So with cloud-based inference, you're essentially sending your data to a company's servers, and their AI models do the processing there. A lot of cloud providers, like AWS with their Bedrock service, they charge you based on how many tokens you use.
Tokens, again, being those building blocks of text.
Right. Or you might be paying for access to virtual machines that are optimized for machine learning, like with Azure Machine Learning.
So with the cloud, you're paying for usage, like a utility call.
Exactly. It's flexible, you can scale up or down as needed, but it can get expensive if you're using a lot of AI. The other approach is edge computing, where you're running the AI model locally right there on your device.
So like AI on your phone or in your car.
Yeah. The big advantage there is that it's faster, there's less lag, and you don't need to send data back and forth to the cloud, but you typically need specialized hardware for edge computing.
And that hardware can be expensive.
It can be. There are fanless edge computers that cost anywhere from a few $100 to several thousand.
So there are trade-offs with both approaches.
There always are, but that's just part of the bigger picture. We've focused a lot on training and inference, but the economics of AI, it goes way beyond that. There's the cost of developing the systems in the first place, the cost of implementing them, the ongoing costs of maintenance and updates.
So let's zoom out a bit and talk about those other financial considerations. First off, let's talk about developing an AI system. What kind of investment are we looking at there?
Well, it depends a lot on the complexity of the project. For small to medium-sized AI projects, you're probably looking at somewhere between $50,000 and $500,000.
Okay, that's a pretty big range.
It is, but when you start talking about large-scale enterprise projects, the costs can easily jump to $500,000 and go all the way up to $5 million or more. And if a company is implementing AI for the very first time, they might have to spend anywhere from $5,000 for really simple stuff to over $500,000 for more complex setups.
So what are the things that influence those development costs?
A lot of things. First, there's the complexity of the project. The more sophisticated the AI model, the harder it is to develop and the more it's going to cost. Then there's the data. You need a lot of it, it needs to be high quality, and you need to clean it, label it, store it. All of that takes time and money.
Right, we talked about data costs earlier.
And then there's hardware and infrastructure. You need computing power, you need access to GPUs, you need cloud services. All of that costs money.
So the development phase is like a mini version of those huge training setups we were talking about.
In a lot of ways, yeah. And then you have the cost of expertise. Hiring good data scientists and AI engineers, that's not cheap. And finally, there's the cost of integrating the AI system into your existing systems.
Right, making sure everything works together smoothly.
Exactly. And that can often require a lot of custom coding and ongoing adjustments.
So it sounds like there are a lot of hidden costs, things that people might not think about when they're first considering AI.
There are, and it's not just about the upfront development costs. There are also ongoing expenses, things like maintenance, security, and just keeping the system running.
Those are essential, but they often get overlooked.
They do, and they can add up quickly. Just for maintenance alone, you're probably looking at $5,000 to $20,000 per year, maybe even more.
Maintenance, meaning like updates and making sure the system is still accurate.
Right. You need to retrain the model as new data becomes available. You need to monitor performance. You need to make sure it's still doing what it's supposed to be doing. And then there's security, keeping the system safe from attacks and making sure you're compliant with data privacy regulations. That can easily add another $5,000 to $15,000 per year, maybe more.
And these regulations are constantly changing, right?
They are, which means the costs are likely to keep going up. And then there's the whole issue of scaling up AI. Once you've got a system working, what happens when you need to use it more, when the demand increases?
That's when those computing costs can really start to bite, right?
Yeah, IBM did a study and found that between 2023 and 2025, computing costs are expected to increase by an average of 89%. And generative AI, the kind of AI that can create text and images, that's a big driver of that increase.
Generative AI is definitely getting a lot of attention right now.
It is, but it's also driving up costs. IBM's research found that a lot of companies, something like 70%, have had to cancel or delay generative AI projects because of those escalating costs.
So it's not just about building the system, it's about being able to afford to use it.
Right. As Jacob Dentic from IBM said, a lot of companies are in the experimentation phase with AI right now. But as they start to deploy these systems more widely, the real impact of these scaling costs is going to hit them.
So there are a lot of financial hurdles to overcome. But there must be ways to manage these costs, right?
Absolutely. There are a lot of smart strategies that organizations can use to make sure their AI spending is efficient. One key area is model efficiency. There are techniques like compression, where you basically make the models smaller and more efficient without sacrificing too much accuracy.
So like slimming down the AI.
In a way, yeah, there are different methods like quantization, where you reduce the precision of the model's calculations, pruning, where you get rid of unnecessary connections within the model, and distillation, where you train a smaller model to imitate a larger one.
And for actually using the models for inference, are there ways to be more efficient there?
Definitely. Techniques like semantic caching, where you store the results of previous queries so you don't have to recalculate them every time, and optimized batch processing, where you process multiple inference requests together, those can make a big difference. And if you're working with large language models, there are techniques for compressing the prompts, the instructions you give to the model, so you use fewer tokens and save money.
Okay, those all sound like pretty technical ways to make things more efficient. What about managing the actual computing resources?
That's where good resource management comes in, and a lot of companies are embracing this idea of cloud financial operations, or FinOps. It's all about carefully monitoring your cloud spending, using tools that give you discounts on compute capacity, adjusting your resources as needed, and negotiating better deals with your cloud providers.
So it's about being smart with your cloud usage.
Exactly. And don't forget about managing your data efficiently, making sure you're not storing more than you need, and minimizing data transfers. That can save a lot of money.
Right, data is a big part of the equation. And we've talked about open source models before. How do those fit into the cost-saving picture?
Well, open source models are often free to use. So instead of paying for a proprietary API, you can use an open source model and potentially save a lot of money.
So it's like choosing a free software option instead of a paid one.
Exactly. And then there's the whole issue of strategy, choosing the right AI use cases, the ones that are most likely to give you a good return on investment, and thinking about hybrid approaches where you're combining custom-built systems with off-the-shelf solutions.
So it's not just about the technical side, it's about being strategic with your AI investments.
Right, and there are real-world examples of companies that are doing this really well. Amdocs, for example, managed to reduce their token consumption by up to 60% during data preprocessing and another 40% during inference by using NVIDIA NAME.
So real companies are seeing real savings.
Absolutely. Perplexity, they reduced their inference costs by 3 times by using a technique called model parallelism on NVIDIA GPUs. And Screenshot, they increased their processing speed by 3 times. They cut their costs by 66% by using a tool called NVIDIA Tensort.
So these strategies are definitely worth considering. What about the choice between using a SaaS AI solution and hosting everything yourself, what's called on-premise?
That's another big decision with financial implications. With SaaS, you're basically paying a subscription fee to use someone else's AI system. It's convenient, you don't need to worry about the infrastructure, but it can get expensive if you're using a lot of AI.
So it's like renting versus owning.
Yeah, kind of. With on-premise, you're buying all the hardware and software yourself, and you're responsible for running everything.
That sounds like a much bigger upfront investment.
It is, but it can be cheaper in the long run if you're using AI a lot.
So it's a trade-off.
Always a trade-off, but that's what makes this whole topic so fascinating. The economics of AI are constantly evolving. It's a dynamic field, and it's going to be really interesting to see how things develop in the coming years.
So where do you think things are headed? What are the big trends to watch out for?
Well, I think we're going to see continued innovation in hardware, more specialized chips, more efficient designs that's going to drive down costs and make AI more accessible. We're also going to see open source models become even more powerful and more widely used.
So AI is going to become more democratized.
I think so. And we're going to see new pricing models emerge, models that are more flexible and more aligned with the value that users are getting from AI.
So it's a pretty exciting time to be following this space.
It really is.
Well, I think we've covered a lot of ground today. Economics of AI are complex. There are a lot of factors to consider, but hopefully this deep dive has given you a better understanding of the financial forces that are shaping this transformative technology.
I hope so too. We've talked about the massive investments in training, the surprising decline in inference costs, and all the other expenses that go into building and using AI systems. The key takeaway is that a strategic approach to development, deployment, and management is essential for anyone looking to leverage the power of AI effectively.
Exactly. And this is really just the start of the conversation. We'd love to hear your thoughts. What are your biggest questions about the economics of AI? What surprised you the most? Keep exploring this topic because it's going to have a huge impact on all of our lives.
Thanks for joining us on the Before AGI podcast for this deep dive. If I enjoyed this episode, please subscribe so you don't miss out on our future explorations into the world of artificial intelligence.
And for those of you who are eager to learn more about AI and maybe even get your hands dirty with some practical applications, check out my YouTube channel, Ian Ocheng. That's Ocheng AI. You'll find tutorials, insights, and all sorts of other AI goodness. Until next time, keep learning and keep exploring.